In this video, we're going to talk about descriptive statistics. If you'll recall, there are 5 important characteristics of data that you want to express or explain whenever you are describing a data set. The first of those is the center, which is a representative or an average value that indicates where the middle of the data set is located. Variation, which has to do with how much do the data values differ among themselves or possibly between different data sets. Third is distribution, which deals with the shape of the data. How is it kind of grouped or clumped together? Fourth is outliers. Are there data values that for whatever reason just don't seem to fit with the rest? Always think about like a horse or something that's outstanding in the field all by itself. It's just outlying in the field and it just doesn't seem to go with the rest of the data set. And then finally, the last one is time, and that we have to recognize that data changes over a period of time. And so we're going to look at the measurements that we would use to help explain each one of those particular characteristics. There are 3 measures of center. I often refer to them as the M&Ms because they all start with the letter M. The first one is the mean, which is what most people refer to as the average. It is technically the arithmetic mean. Of the 3 measurements, it is the most important because the mean is used in other statistical calculations, and it also, the calculation of the mean involves all of the data. So it is the most important of all the different measures of center because it does use all of the data and it's used in other calculations such as the variance. The mean is also a unique value to the data set, but it can be affected by outliers. If you have one or several outliers that don't seem to fit, it can cause the mean to be too low or possibly to be too high. So it can be inflated or deflated. So you have to be aware of that and pay attention to whether or not your data set has outliers. The second measure of center is the median. The median, similar, think about the median of a road, is in the middle, and it is the middle value when the data is ranked or ordered from low to high or high to low, whichever way you prefer, but it's the one that's in the middle. It divides our data set so that 50% of the data are below the median, and 50% is above the median. The benefit of the median is that because you're not really calculating, you're just locating the number that's in the middle, it is not as affected by outliers. So if your data set does have a lot of outliers, it may be to your benefit to use the median as opposed to the mean. Then we have the mode. That is the third measure of center. The mode is the data value that occurs the most within a data set. The mode is the only measure that can be used with qualitative data because we can talk about which category occurred the most, which one was most popular, which one was most common. I suppose the challenge with the mode is that it's possible a data set does not have a mode, that there is not a particular data value that occurs more than any of the others. It's also possible that you could have multiple modes where you have more than one number that occurs an equal number of times, and so that would then represent the mode. Next are the measures of variation. There are 3 of those as well. The measure of variation, first off, is the range. The range is the simplest to calculate. It is simply the maximum value minus the minimum value. And again, that just gives us a very broad stroke idea of how much the data values vary, especially if you don't have access to some form of technology, calculator, computer, something like that. The range is one that you can calculate on the fly pretty easily using paper and pencil. Next is variance. Variance is actually probably the best or the ideal measurement or measure of variation to use, since the formula lets us look at how each individual data value differs from the mean. You look at the relationship between each individual data value and the mean, and it's what we call an unbiased estimator, which means that as you're looking at your small group or your sample and calculating the variance, that variance for the sample tends to target and hit the bullseye on the target almost every time for what the variance would be for the population. It doesn't tend to overestimate or underestimate. It tends to be hit the target and hit the bullseye each time when you look at the relationship between the variance of the sample and the variance of the population. But there is a serious disadvantage to the variance, because the formula, which I'm not showing you because we're going to use the technology to do the calculations, but in the formula you wind up having to square some values, and because you square the values, your units then become squared. So we would have to talk about square dollars if we were looking at the cost of a textbook, or if we were looking at salaries, we would have to talk about square dollars, or we would have to talk about square years or years squared if we were talking about age. So it makes it very difficult to interpret, because in our minds we don't tend to think about those particular units being squared. We don't usually talk about dollars squared or years squared. So what we do mathematically, we're able to undo a square by taking the square root, which leads us to the third measure, which is the measure of variation. And it is literally, by definition, the square root of the variance. And once we take the square root, our units return to the original. So now we can go back and talk about dollars or years in the original context, which makes it easier for interpretation. So of these three, we tend to use the standard deviation more often than any of the others. The standard deviation is the best of the three, primarily again because it uses all of the data values, and it's also used in other calculations. You have to think about how would you interpret it. The standard deviation gives us an idea of how a typical member of the data set differs from the mean. The higher the standard deviation, the more spread out or the more varied your data is. And so, again, you have to look at that relative to the data set or relative to each individual data set. Then we have, oh, and by the way, the standard deviation is never a negative value, because when you take the square root of a number, the square root, you never get a negative number. Then we talk about measures of position. Measures of position, we talk about percentiles. The percentiles are used a lot in education and health-related fields to look at how a particular individual compares to a group. You'll see this a lot in education in relationship to any kind of standardized test, whether it's SAT or ACT. You can look at the percentile rank that a particular student is in relationship to all of those who took the test. Same thing in health-related fields. I know when I take my daughter to the pediatrician, we get a report, and on that report it gives me an idea of where she is based on her age and her height, her age and her weight, and again, whether she is developing on average, or if she's perhaps going to be extremely short or extremely tall based on her particular percentile ranking. Percent literally means per 100, and so what a percentile does is it divides the data set into 100 equal-sized groups containing 1% of the data each. Always think about having like little cubby holes or mail slots, and I have 100 mail slots, and I have to figure out where each particular data value is going to fall. Again, we can use percentiles to compare an individual to the national norm. So you'll again see that some in psychology if you're looking like at IQ scores and that sort of thing. The important thing to note about percentiles is how you interpret it. A percentile is interpreted as the percentage of data values that fall below the specified rank. So, for example, if your score report for the SAT says you scored in the 87th percentile for the English portion, that means that 87% of all the people who took the SAT English portion scored below you. Okay, it's always below that particular rank. There are lots of different ways to calculate percentiles, and so it oftentimes depends upon the researcher. So we're not going to spend a lot of time looking at how to actually calculate percentiles because, again, there's lots of different formulas and different ways to do that. We are going to focus on a subcategory of percentiles called quartiles. Quartiles are special percentiles. It's a subcategory, and it separates the data into 4 different groups or into quarters, so that instead of having 100 equal-sized groups, you'll have 4 equal-sized groups, and each group contains 25% of the data. The quartiles are useful in the sense that they help us to determine whether or not a data set has any outliers. And again, the importance of outliers are because they can affect the calculations of your mean and other values. Your quartiles do not necessarily have to be one of the actual given data values. It can be, but doesn't have to be. And again, it's the same interpretation as we had for percentiles. It's interpreted as the percentage of data values that fall below that particular rank. Our first quartile, which is denoted by Q1, would be the value at which 25% of the data falls below that particular value of Q1 and 75% of the data is above. So it's like your 25-75 split. The second quartile, which corresponds to the median, divides your data 50-50 so that you have 50% below and 50% above. And then finally, your third quartile divides 75-25 so that 75% of the data is below Q3 and 25% is above Q3. Now, Minitab or other statistical softwares, your calculator will calculate the measures of center, the measures of variation, and the measures of position for you. And so in a separate video, you'll be able to see how Minitab does that for this particular course. Another piece that comes out of the quartiles is what's called the interquartile range, and it is Q3 minus Q1, and it represents the middle 50% of the data. And again, we're going to use quartiles ultimately to help us decide if there are any outliers. There are lots of different ways to display descriptive statistics. We don't necessarily display all of them. You can, but one way is to use a frequency distribution, which takes your raw data and puts it into somewhat of a table format. And you can use a frequency, which would be the count, or how many in terms of a number do you have. But we also look at percentages. Percentages again allow us to compare different sized groups. You can also create a summary table, and again, there's lots of different formats depending upon what descriptive statistics you need and or want to communicate. One of the most common is a 5-number summary. In the 5-number summary, you include the minimum value, quartile 1, median value, quartile 3, and the maximum. You'll also sometimes see in a 5-number summary, it's no longer a 5-number summary then, but they'll also include the mean and the standard deviation as well as the sample size. Again, it's important to know the mean, the standard deviation, and the sample size because those pieces of information are often used in other statistical calculations. There are also a variety of graphs that you can use to display them. We can use a histogram, a line graph, and a box plot. And I've kind of given you some examples. I just Googled and found a variety. The top table 3.1a here would be similar to a quantitative frequency distribution. They've grouped the average number of glasses of water per week, and so we can see that 20 residents drink between 0 and 1. So this is what we would often call a grouped frequency distribution. I have given you a table of summary statistics that display your 5-number summary along with the mean, standard deviation, and sample size. And then here's another way, especially if you're looking at, if you're looking at separate categories, whether they're an athlete or non-athlete, and it gives you the mean, the sample size, the standard deviation, the minimum, and the maximum. So again, it can be displayed in a variety of ways depending upon what information you need to communicate, how much space you have, and that sort of thing. And then there's also some examples of the various graphs. The graph here on the top of students' ages is a histogram, and we could talk about the distribution, whether it's skewed left, skewed right, or symmetric. And then we also have a box plot. One of the benefits of the box plot is these little stars here are the way that they indicate that there are outliers within this particular data set. So they each have their usefulness. Again, it depends upon what kind of information you're trying to communicate and so forth. And as I mentioned earlier in a separate video, you can review how to use Minitab to calculate your measures of center, variation, and position.